this is Tim Sandle back with you with another video to be used for your shift handover. And as before, we're making one subject and we're talking about 3 points around that subject. And again, hopefully bringing something slightly different to your shift each week. So today's subject is going to be active air samplers. Before I begin, there were a few comments about kind of product placement last week. I've no idea what anyone's talking about there. I'm just going to adjust my bookshelf before we begin. Okay, so active air samplers. So what 3 points can we make about those? Okay, well the first thing is that there are three kind of main models of active air sampler on the market. And these are impaction, filtration and centrifugal. Filtration ones are quite rare. They're often found in isolators and they use a dissolvable gelatin based membrane. So they suck the air in, filter the organisms onto the membrane is then transferred to a nutrient medium. Centrifugal ones are ones that are sometimes used in grade C and D areas. And these have heads that spin round rapidly and they're drawing in air, and obviously in that air there's going to be some microbial carrying particles, and the centrifugal force forces the air through and throws off the particles and they get deposited onto an agar strip. But the ones that you'll be most familiar with, the most common models of air sampler on the market, the impaction air sampler, these ones have 96 holes in the air sampler and they pull in a cubic metre of air, and the air is forced through at reasonably high velocity and the holes force that velocity through, and the air strikes the agar plate and the force of impact throws the air off and leaves microbial carrying particles behind. So that's the first point. That's the impaction air sampler, which is the SAS model, which is yellow in colour, and that stands for surface air sampler. Second point is that not all air samplers are the same. They're not all of the same efficiency, and there's a big variety across the marketplace. And the efficiency of air samplers is defined by something called the D50 value. And the D50 value is the smallest size of particle at which point 50% of those particles and microorganisms could be recovered. So the smaller the D50 value, the more efficient the air sampler. And then it follows for larger particles, as you move up, that efficiency increases. So naturally with the SAS samplers that we use, these have a low D50 value and are therefore pretty effective samplers. Okay, what shall I do for the third point? Okay, how about good practices? Okay, so there are some good practices to do with active air sampling. The first thing is to always avoid putting your hand over the head of the sampler, because you could then deposit contamination and we could get false positive. The same level of care and attention needs to be paid when positioning the agar plate. Obviously don't want ever to touch the agar. The other part of the third point is that with active air samplers we need to make sure that they've worked. And the way we can tell they're working is the 96 head will cause the agar to dimple. And if you can see the dimples, then we know there's a good chance that it has taken in that cubic metre of air. Okay, and then the final part of the third point is that it's always important to take air samplers at the same length of time, the same places within the fill. So the start air sampler needs to be taken very shortly after the fill starts, and certainly before the first 50 vials are filled. And the same with the end air sampler as well. That needs to be taken before the fill finishes and to be finishing as there's still around 50 vials to go. And for fills that are larger than 10,000 vials, then we have the mid-air sampler as well. Okay, so that's it, coming in at about 5 minutes. I've been Tim Sandle, and I wish you all the best with the remainder of your shift. So time for me to go, and wish you good luck. See you soon. Goodbye.